today's special guest, Dr. Avi Loeb. In looking at Dr. Loeb's extensive bio, I had to try and condense that down. His bio would take probably most of the meeting in order to properly give him the justice that he deserves. But Dr. Loeb received his PhD in physics from the Hebrew University in Jerusalem at the tender age of 24, which is pretty remarkable, actually. He led the first international project supported by the Strategic Defense Initiative during the 1980s. And he's the Frank B. Baird Jr. Professor of Sciences at Harvard University. He's the director for the Institute of Theory and Computation within the Harvard-Smithsonian Center for Astrophysics and heads the Galileo Project. He's also the author of more than 1,000 papers, 8 books, and including most recently Extraterrestrial and Interstellar. You can find the address to his website on our webpage and our social medias. So welcome, Dr. Loeb.
Thank you so much. I hope you can hear me.
Yes.
And I just need you to, oh, perfect. You allow me now to share my screen. So I will make a presentation of some slides, giving you background about my work, and then I'll be glad to answer any questions you have. So I hope it will be mostly a conversation. So this was the title of the New York Times Magazine article that came out a couple of years ago. And I'll try to explain my interest in the subject of searching for extraterrestrial intelligence, or more specifically, objects near Earth that might have been manufactured by other civilizations in the Milky Way galaxy. And of course, from an astronomer perspective, it's very unlikely that we are alone, that we are unique and special, because there are 100 billion stars in the Milky Way galaxy, and at least a few percent of those stars have an Earth mass planet roughly at the same separation Earth is from the sun. So it would, there are billions of Earth-Sun analogs, and most of the stars formed long before we came to exist, billions of years ago. So when Enrico Fermi asked, where is everybody? You know, that was very presumptuous. There are many lonely people who ask this question, and what you tell them is, you know, you are not that attractive. You should go to dating sites, or at the very least, look through the windows of your home to find a partner. And Enrico Fermi didn't build a telescope. He didn't do any search. And most scientists just keep repeating this question and expressing their belief or conjecture without any evidence. And that's not the scientific approach to such a question. And what is often said is that the idea of something like us existing elsewhere is an extraordinary claim that requires extraordinary evidence. Well, first of all, it's not an extraordinary claim, because we know that, you know, we exist on a planet like Earth, and there are many similar circumstances elsewhere. And since most of the stars formed billions of years before the sun, we are probably not the first civilization to have emerged in the Milky Way galaxy. And ordinary claims like something like us is reproduced under similar circumstances elsewhere requires ordinary evidence. And when people make this statement, they often use it to argue that there shouldn't be any funding for the scientific research associated with the search for intelligence elsewhere. And so the focus of the astronomy community, the mainstream, is on searching for microbes. My point is that even though microbes might be far more abundant, their signatures are very subtle, and it's better to hedge our bets, because if we do find a gadget from another civilization near Earth, then it would be clear evidence that not only life exists out there, but in fact intelligent life. And you know, usually what we tell ourselves is a self-fulfilling prophecy. So it's much better to be an optimist. And currently, the scientific community is not investing any significant funds in the search for extraterrestrial intelligence, while planning to invest more than $10 billion in the next 2 decades in the search for microbes in the form of using the Habitable World Observatory that is currently the highest priority in the astronomy community. And personally, one reason that I seek higher intelligence in interstellar space is because I don't often find it here on Earth. As I mentioned, it might well be that microbes are all around us, and including in the solar system, under the ice of moons or comets. And the search for microbes on exoplanets is focused on the chemical fingerprints that they leave in the atmospheres of those planets. But we haven't checked our backyard to see if there is any technological objects near us. That was not done systematically so far. And there could be other technological signatures, for example, industrial pollution in the atmospheres of exoplanets, or artificial lights, city lights on the night side of exoplanets. Nobody is allocating funds to do this kind of research. And I actually, after the last election, there was a podcast in which Peter Thiel argued nobody should bet against Elon Musk. And a day later, I placed a bet against Elon Musk because he argued that we should go to Mars because we're probably alone and therefore we have a responsibility to survive if something bad happens on Earth. And I argued that we are probably not alone. And so he made the wrong premise, and I was willing to put 1% of my net worth against 1% of his net worth to demonstrate if we use this money to search. I'm willing to bet that we will find a more accomplished space entrepreneur in the Milky Way galaxy than him. Over the past 13.8 billion years since the Big Bang, I'm willing to bet that there was someone more accomplished than him, and we could find the evidence for that. And unfortunately, he did not put the $4 billion I was asking for, but he changed his tunes a few months later and basically repeated what I say, that we should search for technological relics. So I only could repeat what Oscar Wilde said. He said that imitation is the sincerest form of flattery. At any event, the scientific community invests, of all the $10 billion in big projects, that includes the Large Hadron Collider or the Webb telescope. And my recommendation is that we invest at least $1 billion in the search for technological signatures from other civilizations. And that is a small fraction of the budget that we allocate to defense, which is $1 trillion within the US and $2.4 trillion worldwide. If we were to use this entire money every year to explore space, we could launch a probe towards every star in the Milky Way galaxy, 100 billion of them altogether, within this century. We could simply send a message to every star in the form of a CubeSat. Within the solar system, the most intriguing place that I would like to visit is Titan, which is a moon of Saturn, because it's the only other object in the solar system that has liquids on its surface beyond the Earth. Earth has water, oceans, lakes, rivers, and Titan has oceans, lakes, and rivers made of methane and ethane. So these are liquid at a temperature that is about 90 degrees above absolute zero, a third of the temperature on the surface of Earth. And what I would like to do is go fishing there and check if there are any fish there, because that would imply that there is life as we don't know it, even within the solar system, in a liquid that is very different than water. There would be a mission that NASA will launch in 2028, just 3 years from now, called Dragonfly, that will explore the possibility of life on Titan. So stay tuned. And getting closer to home, as you well know, the Director of National Intelligence submitted 3 reports to the US Congress between 2021 and 2023, and that led to the establishment of the All-Domain Anomaly Resolution Office in the Pentagon. And the reports basically said that there are unidentified anomalous or aerial phenomena, objects in the sky that the intelligence agencies or the military cannot figure out. And that's an amazing admission in their own self-incompetence. I mean, they are being paid the billions of dollars every year to figure out what flies in the sky above the US. And they are admitting that they're not doing their job. So my point is that, this is a serious matter that cannot be ridiculed by the scientific community, and therefore we should figure out what these objects are. If they belong to adversarial nations, then we're helping national security. But even if 1 in a million is from outside of this Earth, that would be the biggest discovery in that science ever made. And so I established the Galileo Project. And I should say, I gave a briefing to the US Congress on May 1st on this issue, and I'll be glad to discuss more. So the Galileo Project was established after the first report came out. And we have one functioning observatory where we get data on about 100,000 objects every month. So within a year, we get more than 1 million objects that we monitor. In the infrared, we look at the entire sky in the infrared, radio, optic, visible band, and audio. And we use machine learning software to analyze the data and look for outliers. So there is one working observatory at Harvard, but actually next week, I'm heading to Nevada to build another one that would be actually more advanced than the one we have. And we already assembled the 3rd one in Pennsylvania. So we have 3 of them. And the one in Nevada would be particularly interesting because we'll have 3 units separated by 10 kilometers from each other. And that would allow us to triangulate and figure out the distances to objects in the sky, and also know the velocity and the acceleration of these objects. So the next 6 months are promising to be very exciting because we'll get a lot of data from all 3 observatories. But the reason that I started being interested in this subject was the discovery of interstellar objects by astronomers. And that happened only over the past decade or so. The first object was a meteor, roughly 0.5 meter in size, that was moving too fast to be bound to the sun by gravity. It was identified by US government satellites. And we discovered it in a catalog of NASA with my student, Amir Siraj. The object was detected in 2014, more than a decade ago. And then another object was discovered in 2017 that was much bigger. It didn't collide with Earth. It was not a meteor, but it passed near Earth. And astronomers discovered the reflection of sunlight from this object. It was the size of a football field, about 100 meters. And it was very strange, very unusual in its shape, because the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And the best fit to the variation of light over time was that of a flat object, pancake-like. And moreover, the object was accelerating away from the sun without showing any evidence for evaporation. It was not a comet. So the question was, what is pushing it? And finally, there was a comet discovered in 2019 that also came from outside the solar system. All of these objects were moving faster than the escape speed from the sun. So these were the first objects reported to have such a high speed. And the first 2 out of the 3 were anomalous. They had properties that cannot be easily explained by the kind of asteroids or comets that we are familiar with. So this is an artist illustration of ʻOumuamua, the second object, the size of a football field, and the artist depicted it as a cigar-shaped object, but in fact it was pancake-like. And the most unusual property that it exhibited was that it had the non-gravitational acceleration, but without showing any evidence for a cometary tail that would explain it by the rocket effect. And I simply said it cannot be a comet. And the comet experts argued, no, it's actually a comet, but you can't see the tail. The situation is similar to Hans Christian Andersen's tale, where I'm playing the role of the kid who says the emperor has no clothes. And here the emperor is ʻOumuamua, this object. And my colleagues are arguing, yes, it does have clothes. They are behaving like the adults in the room. It does have clothes, but you just can't see them. And the reason it's called ʻOumuamua is because it means in the Hawaiian language, a scout. This object was discovered by a telescope, a survey telescope in Hawaii, and was flagged because it came close to Earth. And I suggested that the push away from the sun is actually the result of the sunlight reflecting from it. So this object is thin and maybe a surface layer, of a bigger object that was torn apart, or a broken piece of another object. And my colleagues were saying it's actually a rock of a type that we've never seen before. Turns out that just earlier this year, I realized that there is a whole class of objects that is well known near Earth that are called empty trash bag objects. These are objects that are pushed by reflecting sunlight, and they are thought to be broken pieces from satellites. But in fact, we know that humans produced a lot of space trash. For example, on January 2nd this year, an amateur astronomer reported about a new asteroid that came close to Earth, and it was cataloged as an asteroid with some name and a near-Earth asteroid. And then within a day later, astronomers realized it's actually moving along the path of the Tesla Roadster car that was launched by SpaceX in 2018. So it was not an asteroid, it was a car. So that's an example of a technological object that astronomers would catalog as a rock of a type that they've never seen before. And there were many such examples. In fact, right now I'm writing a paper about 14 objects that were cataloged as dark comets that may all be space trash from the 60s or the 70s. And even the survey telescope in Hawaii that I mentioned that discovered ʻOumuamua, its name is Pan-STARRS, even that one, 3 years later after discovering ʻOumuamua, discovered another object, 2020 SO. And it was cataloged as an unusual object because it was clearly pushed by reflecting sunlight. But then within a month, it was realized by the astronomers that it was actually the upper stage of a Surveyor 2 lunar mission that was launched by NASA back in 1966. So given that we produce space trash and that some of these objects are pushed by reflecting sunlight, why not imagine that ʻOumuamua could have been a similar object produced by another civilization? We know these guys were produced by us. The question is, who produced ʻOumuamua? And it's really a cheat for astronomers to call some of these objects that exhibit non-gravitational acceleration, to call them dark comets. Because by doing that, they basically suggest that they are comets, but comets are identified by their cometary tail. And so if you call an object that doesn't have a cometary tail a comet and just say that it's a dark comet, it's just like, calling a zebra without stripes a zebra, even though it's a monkey, because it doesn't have stripes. That's the distinguishing feature. Or you can think of a monkey without a visible tail that it would actually be a koala, a very different animal. So dark comets may not be comets at all. So why call them comets? And you often find that in the scientific literature where people are assuming something, and by calling it with a name without knowing what it is, they're basically trying to shove the anomalies under the carpet of traditional thinking. And that's a cheat, because we don't know what these objects are. So my point is that there might be objects coming near Earth from interstellar space that might be technological relics. For the first time, we discovered a few of them over the past decade, but we should do a systematic search. And the next Copernican revolution might be that not only that we are not at the center, the physical center of the universe, we're actually not at the technological center of the universe. We are not alone. And with an investment of $1 billion, I wrote a paper about it, we can actually launch a space telescope that would search through all the objects near Earth that might be of interstellar origin and check if there is any technological object among the rocks that arrive into the solar system from other stars. By the way, just to calibrate, there are of over 1 million objects that are roughly 1 meter in size within the orbit of the Earth around the Sun at any given time. 1 million interstellar objects. And the only ones we can see, 1 meter in size, are not reflecting enough sunlight for us to detect them with the best telescopes we have. So the only ones we can detect are those that collide with Earth, like the interstellar meteor that I mentioned, because then they burn up in the atmosphere and produce a fireball. As I mentioned, most stars form well before the sun. The sun is a latecomer. And you might ask, where will Voyager, our own spacecraft, be in 1 billion years? And the answer is that it will go to the opposite side of the Milky Way galaxy. And that means that other civilizations that predated us by billions of years, could have sent space trash that would reach us by now if it moves roughly at the speed of our own space trash. And we haven't really searched systematically our backyard. So there was for 65 years a search for radio signals from other civilizations. That is just like waiting for the phone to ring. And you might not be waiting at the right time. If the phone rang 1 million years ago, you wouldn't hear it. I'm suggesting checking our mailbox. That's a very different method to detect evidence for other civilizations. And that was not done. And in fact, the SETI community is very hostile to this method for a reason that escapes me. I don't really understand that. So a couple of years ago, I decided to lead an expedition to the Pacific Ocean in search for the materials left over from the fireball of the first recognized interstellar meteor. And I reached out through the White House to the US Space Command, and they released more data about this meteor. They also confirmed through an official letter to NASA that this meteor was indeed interstellar at the 99.999% confidence. And they released the light curve from the fireball that had 3 flares, and they implied that the object disintegrated only 20 kilometers above the Pacific Ocean in the lower atmosphere, implying that it had a very high material strength that was able to sustain the enormous pressure given its high speed. It was actually tougher than iron meteorites, tougher than all meteorites cataloged by NASA, up to 1,000 of them by now over the past decade. So that meant that it might have been made of materials of unusual strength. And so that made me curious to figure out whether it was artificial in origin, a Voyager-like meteor. So I led an expedition. It cost $1.5 million, and we received a donation for that amount, and went on a ship that is called Silver Star that you see here. This is the team of researchers that came with me. And we built a magnetic sled that you see in the top middle. That's a sled 1 meter by 2 meters, about 200 kilograms, that had magnets on both sides. And we placed it on the ocean floor that was 2 kilometers deep at that location, the location of the fireball of this meteor. And we surveyed that region. We went back and forth 26 times. And we collected materials from the ocean floor, the magnetic particles, with the hope of finding some meteoritic material from that meteor, interstellar meteor. There was a Netflix documentary team that came with me. They are producing a documentary about my research, and it should come out in early 2026. I usually jog every morning at sunrise, and you can see me jogging at the lower left and middle panels. And the director of this filming crew was asking me, Avi, it looks like you are jogging. Are you running away from something or towards something? And I said both. I'm running away from some of my colleagues who have strong opinions without seeking evidence, and I'm running towards a higher intelligence in interstellar space. And so we collected materials there, and with the hope of finding meteoritic debris. You can see here the magnets on the left side, one of the rainy days where we collected we would bring the sled on the deck and then scrape the magnets for any material. And then eventually, after 2 weeks being on the ocean, I shipped the material that we collected in this black suitcase to my home using FedEx, and then brought it to the laboratory of my colleague at Harvard, Stein Jacobson, that you see on the right side here. He's a world-renowned geochemist that has the best equipment in the world to analyze the meteoritic materials that we brought back. And on my other side is Sophie Bergstrom, who was a summer intern that year with me. And she actually went through the material and identified these molten droplets that represent meteoritic material. She found most of them. Altogether, we had 850 of them. Just to give you a sense, the most accomplished ocean expeditions in the past would collect somewhere between 10 to 80 such spherules, molten droplets. We brought more than 850 of them. And it was easy to identify them on the background of sand. You can see it here. We would pick them up with tweezers, and they would look very distinct from the background. There were different types of spherules that we identified in the laboratory of Stein Jacobson, and about 80% of them looked like solar system debris from meteors that came from the solar system. These are the ones on the left that we labeled them primitive. And then 20% appear to be different. We call them differentiated because they lacked some elements, and they had some elements that are highly abundant, and that meant that elements were differentiated. And so altogether, we found that about 10% of the material composition was very different from solar system materials. And we show it here. This is the abundance of elements as a function of the volatility of the elements. As you move to the right, elements are more volatile. And what we found is that this 10% of the spherules, the molten droplets, had enhanced abundances, for example, of beryllium, lanthanum, uranium, by up to a factor of 1,000 relative to solar system materials. And then, of course, volatile elements were depleted because this material came from an explosion, a fireball that evaporated these. So it's not clear, based on this element pattern, whether it's natural or artificial. I actually wrote a paper that explains this abundance pattern, perhaps from a natural origin. If a planet like the Earth was orbiting a low mass star, the most abundant type of star, which is about 10% of the mass of the sun. These are the most common stars. The sun is not a common star. And these common stars are also a tenth of the size of the sun, so they're much denser than the sun by about a factor of 100. So if you bring a planet like the Earth close to such a star, it would spaghettify, the star would spaghettify the planet, create a stream of rock, molten rock, out of it, and half of the material will be ejected to interstellar space. And that process could explain potentially the abundance pattern that we found. So there is a natural mechanism of creating that, but we don't know for sure because we haven't found big pieces from the original object. And just a few weeks ago, there was a report about that about 0.2% of all meteorites appear to be outliers. They cannot be associated with any planet in the solar system, planet or moon. And they have very unusual composition. And I realized that we can actually order such pieces from eBay. And so we ordered them, and we are currently studying two of these samples, and we are trying to figure out whether this might be of interstellar origin, because based on the statistics of interstellar meteors from the catalog of NASA, we expect roughly 2 in 1,000. So 0.2% is exactly the fraction of outliers that we might expect from interstellar space. So we are currently studying those in the laboratory. Actually, I just heard the preliminary report this Friday about it. But we really hope to go again to this site of the interstellar meteor, because we want to find bigger pieces that would tell us the structure of this object. And that would be the next expedition. So this was a photo from the last day of the previous expedition. I was looking at the sunset together with the party chief, the navigator on this expedition, Art Wright, who is 88 years old, and he was a commander of a destroyer during the Vietnam War. And I really liked him a lot because he wouldn't say much, but everything he said was true. And he really solved many of the problems we had on the expedition. So we were contemplating the next expedition to find bigger pieces. And we already have the ship that we want to use. It's called Nautilus. And we would employ a robot, a remotely operated vehicle that we would put on the ocean floor. You see it on the left. It's called Hercules. And it will provide us with a video feed so we can see what we are picking from the ocean floor. The only thing that we are missing is funding. It would cost $6.5 million for us to operate this system. And we're waiting for a donor that would provide us with the funds. Everything else is ready. Now, also in 2025, actually on Monday, just 2 days from now, the first images from a new observatory in Chile will come out. It's called the Rubin Observatory. It was funded by the National Science Foundation and the Department of Energy. And it's an amazing observatory that will survey the southern sky every 4 nights. And it could detect ʻOumuamua-like objects every few months. So if there are any siblings in the family of ʻOumuamua, we might find them in the coming months, and that's very exciting. This observatory will employ a camera with 3.2 gigapixels, so it's about 1,000 times more pixels than your cell phone camera. And here you see an image of that camera. It's roughly half the height of a person. It's a huge camera. And we will see the first images from the Rubin Observatory on Monday at 11 a.m. Eastern Time. If you just search on Google the Rubin Observatory first images, you will see the link that you can use to watch the announcement of the first images. And that's just the beginning. This observatory will operate for many years to come, and we hope that it will show evidence for more objects like ʻOumuamua. So altogether, the 2025 will be very exciting because we will have 3 observatories of the Galileo project collecting data on a few million objects this year, and then maybe some of them would be unidentified anomalous phenomena that we could then identify. So we will identify the unidentified. And moreover, there would be, hopefully we will get a donation to conduct the expedition to the Pacific Ocean to find bigger pieces of that interstellar meteor. And finally, the Rubin Observatory may find more objects like ʻOumuamua. So thank you all, and I'd be glad to answer any questions you have.
So thank you for that. That was actually very interesting, and I love your sense of humor. You got quite a few laughs here, so thank you for that. It's a
yeah. My wife says that even though I never intend to be funny, that I am funny. So I guess that's the best compliment you can get.
Well, and there you go. You just got a few more laughs here. So I want to take a moment and just say thank you. And
Okay.
the reason I'm saying thank you is I remember back in 2017 when you started talking about ʻOumuamua, and the academic community wasn't maybe very nice about that. And I just really appreciate you doing what you did. You really opened the door to academia everywhere to be able to actually touch this subject. It was.
Thank you. I mean, my biggest reward is actually that the Galileo project is employing a few postdoctoral fellows and students. In fact, this summer, someone came to my home and gave me a check for $20,000 that can allow me to employ 5 summer students. And I just advertised those fellowships, and within a day, I got 5 applicants that are currently helping us. And the same is true about the postdoctoral fellows, that we're always waiting for an opportunity to conduct research on this subject. And they thought that my line of research is a breath of fresh air. Now, if you ask why would my colleagues be so hostile, that is a complicated question and really unfortunate one, because they're willing to invest $10 billion in the search for microbes. It's not as if life in the cosmos is of no interest, but putting 10 billion towards that without any money towards intelligent life is really, I think, inappropriate, and it's not wise. And my conclusion is that common sense is not common in academia.
I would have to agree with that sometimes. I think it really opened the doors. Recently, a colleague of yours in the Galileo project, Laura, did a presentation at a conference that I was at. And I've watched I've watched that organization increase in size exponentially almost. And I think that you really did lay the groundwork for some of that to happen. So
thank you. And actually, speaking about Laura, there was, if anyone wants to see, there was a Bloomberg News report. There was a video, a documentary that is 15 minutes long that you can find on YouTube, Bloomberg News from this month. And there was also an article, but that's behind the subscribers wall, so you may not be able to get there, but the video is open on YouTube and you can see it. And she just got offers for faculty positions. So even though it sounds as if it's a risky path to follow, I mean, there are opportunities in it. And I really don't understand my colleagues because, for example, on many other frontiers, they made mistakes that cost billions of dollars that didn't lead anywhere. And I can mention a few of them. The Large Hadron Collider was searching for supersymmetry, a new symmetry of nature, and it cost $10 billion. And this was the fundamental symmetry, supersymmetry, that was the foundation for string theory, a subject that the vast majority of the theoretical physics community was working on for 5 decades, for 50 years. Okay, so that was extremely popular. They assumed that it must be there, supersymmetry, and they built a whole castle on this foundation for 50 years. And then the Large Hadron Collider looked for it and didn't find it. Okay, didn't find it in the natural regime of parameters that they assumed. And then in the search for dark matter, we have been searching for particles that people said must be there. It's very natural. Everyone was celebrating, giving each other awards about predicting properties of these particles, like weakly interacting massive particles. We invested billions of dollars. We haven't found anything. Now, my point is just put the same amount of money in the search for technological signatures. And if within 5 decades we don't find anything, we'll be at the same point as these communities are, okay? And these are mainstream communities. So claiming we don't want to take any risks, we don't want to waste taxpayers' money, is really inappropriate, because if you were to ask taxpayers about it, they will tell you that the question of whether we are alone is far more interesting to them. So when you ask the taxpayers what are they willing to fund, they will tell you this subject, not the other subject. Yet on the other frontiers, we spend the money, we didn't find anything. So you can't say, oh, the mainstream is always, has a very solid assessment as to what might be found. This is definitely not the case. For the last few decades, there was no fundamental discovery in physics. And one reason is perhaps because the actual risks are not being taken, because you can make new discoveries only if you allow yourself to take risks. If you are entrapped in an echo chamber, everyone is saying the same thing, but it ends up not being reality, then you just go nowhere. I mean, so much of the funding and state of mind right now within the physics community is based on sociology. It has nothing to do with what nature is. Thinking about extra dimensions, like we don't know if there are extra dimensions. All we see are 3 dimensions. And if you were to go 50 years back before string theory and you would say, I believe in extra dimensions, people would put you in a mental hospital, because we know that there are only 3 dimensions. But somehow it became popular and everyone speaks about it, and it sounds extremely sane to talk about extra, even though we haven't found any clue for it. So why is that more reasonable to pursue for 50 years than technological signatures? In other words, copies of things that we do elsewhere where conditions are similar.
I absolutely would agree. I know we have questions. Our format is that we are live in person in 2 locations, and then we have people that join us online. So I think I'll start with our Fargo location, then we'll move to Grand Rapids, and then we'll take a look at some of the questions online. So
by the way, is Fargo the same place as there was a movie, right?
Yes. Oh, you betcha.
Of the Coen brothers, and I love that movie actually.
Yeah, and we actually do have the wood chipper on display at our tourism information building. Okay. So yeah, if you ever want to see the wood chipper, it's here in Fargo. Yeah, same place. Okay. So do we have any questions here in Fargo? You can either come up, you can say it, and I'll just repeat it to him. I don't want to put anybody on the spot to be in front of the camera. So the question is, what factors caused you to choose the locations for the Galileo sites, the Pennsylvania and Nevada?
Okay, so Pennsylvania and Nevada was simply dictated by the people who funded those observatories, because each of them, each of these observatories costs between $1 and $2 million. So in the case of Pennsylvania, there was the Richard King Mellon Foundation that was willing to fund it as long as it's in Pennsylvania. So, and in the case of Nevada was similar. There was a funder that provided the funds under the condition that it will be there. So we are really mostly limited by funding. But of course, the more observatories, the better. I mean, I get a lot of emails from people saying, I'm willing to give you my backyard, but it's not really the issue. The issue is not the location, the real estate. It's the funding for the observatory.
I have a follow-up question to that. So particularly in Nevada, obviously, it's a well-known place for, our government, the U.S. government, to
Area 51.
Yeah, to test things, and there's a lot of restricted airspace. So I'm wondering if there was any pushback or challenges because of that. Did you have to work with the U.S. government?
No, I mean, my policy in terms of the Galileo project, I don't want to get close to strategic sites, that may raise concerns from military or, other agencies. And because, there are many reports about unusual objects near strategic sites, like nuclear plants, like military bases and so forth. But I mean, based on all the data we have, it's not at all clear that there are more objects there. It's just that there are more eyes looking at the sky there because of they're trying to protect these sites. And so we want to go actually to other places. First of all, not to interfere with classified activity. Why should we get into that? And secondly, also to explore the question of what happens in locations that were not monitored as much, and yeah, I mean, even though we go to Nevada, it will not be just very close to Area 51. My personal assessment is probably, the Department of Defense is using that location as a test bed for new technologies. Now, of course, there are all these stories that perhaps they retrieved some craft from alien civilizations and are studying it there. When I visited Washington on May 1st, I gave a briefing in Congress. The day before that, I went to the Pentagon to meet with the people who lead the AARO, the All Domain Anomaly Resolution Office. And I asked the AARO people, I said, as you look back at all these hundreds of reports, did you find anything that looks unusual? And they said, no, we didn't, except for some reports by FBI agents. So I said, okay, well, then a day later, I was in Congress, and next to me was Eric Davis. And after my briefing, he was asked about it, and he said, oh, the US government has a dozen craft that were retrieved, and they had biological pilots, and there are 4 types of aliens that they have, and so forth. So, okay, so within one day, I heard 2 versions. I mean, the AARO version was that they have access to all the information within government. They don't have any clue whatsoever to anything unusual. And the other one was Eric Davis, saying, oh, there are 4 types of aliens that are that were recovered. So now the question is, who do you believe? And, I'm not a psychologist. I cannot really figure out who is cheating and who is, maybe both of them are sincere, but definitely only one of them can be correct. Okay. So, and my approach as a scientist is either you show me the data and I will be able to tell you what I think it is, or if the government doesn't show anything, just get the data myself, because, the sky is not classified, the oceans are not classified. We should be able to look up, nobody is forbidding this. And if there are objects that came from another civilization, we will find them.
Indeed. I think if I had to choose between which one I would believe, Dr. Davis would probably be the one I would be more likely to believe. But
yeah, I mean, I can, yeah, anyway. Yeah, I agree, but I mean, it really depends on the evidence, and I would love to see evidence to support it, because otherwise I don't know whether I should believe it. I mean, just believing people based on what they tell you is not a good approach, because we know of many people that were put on death row after someone testified that they really committed the crime, and then the DNA evidence showed that they should be exonerated. So it's really, you know, science is the only path for us to figure out the truth rather than listening to people.
Agreed. Jer, is there anyone that has questions in Grand Rapids?
Yeah, we got a couple of questions here, I think. Dr. Loeb, thanks for being here today with us. It really is an honor. Thank you. If anybody online has a question, just use the reaction thing to put up your hand. We'll get to you. So here we go.
I really appreciate that you're here. This is awesome. I was wondering if you had any theory about what is so interesting about Antarctica.
Oh, maybe you're referring to a particular object or event there, but in general, Antarctica is a good place because the ice preserves whatever falls there, and there is not as much weathering as elsewhere. And so, for example, it's a good place to collect meteorites, and in fact, such work is being done there. And but also technological objects that may have landed on Earth, you know, that would be because the ice is white, and if you were to use data from satellites, you could identify unusual objects over such a smooth background. And another place where you might easily identify objects from above, from satellites, is the Sahara Desert. And the thing is, I'm sure the US government has plenty of satellite data, but it's all classified. And, you know, in principle, you could see objects that may not be human-made from satellites much more easily than looking up from the ground. So anyway, I do think Antarctica is a good place to search. Going there is very, you know, the weather is so cold, but looking from satellites would be a very good way to see if there's anything unusual over there.
All right, thank you. We got one more here in Rapids.
Yes, my question is, I was wondering if you're following the BLC1 Technics signature from Proxima Centauri.
Yeah, so
and if you have a comment on that, or if you have any more recent information on that.
Yeah, so when it was first announced or mentioned, the claim was maybe it's a radio signal that comes from the nearest habitable planet, Proxima b. It's near Proxima Centauri, which is the nearest star, and we know that there is a habitable planet next to it. It was discovered in 2015. So the claim was, oh, there is a radio signal coming from that direction. Maybe it's from the habitable planet. Maybe there is a technological civilization. Well, first of all, you know, this is the nearest star. So if it has an active civilization, it means that they are everywhere. Like there are billions of them, you know, not just because this one is the nearest star. So what's the chance that it will have anything? But after that, I also looked at the signal, and you know, if it's coming from a planet in the habitable zone around the star, you would expect the frequency of the signal to drift in a very predictable way, because the planet is moving around the star with an orbital period of 12 days or so. You know, this is a dwarf star, so the planet is closer in. So if there are any living intelligent beings there, they celebrate their birthday every 11 days or 12 days, rather than a year. So there must be a lot of birthday parties over there. But the thing is that it's such a short period that you should see modulation of the signal by the Doppler effect, the frequency would drift back and forth, and that was not observed. And then about half a year later, the team that detected the signal claimed that it's more likely to be from Earth. They published the paper. I didn't follow it after that, and I know that more recently they had more data, but I haven't heard them claim that they think it came from outside of, from far away, rather than interference on Earth. I haven't heard that. So I would, based on the original data, I would say it's probably from Earth, interference from.
All right, thank you. Well, I guess we'll move to online. Jamie, can you unmute yourself?
Hi, so I have a lot of questions. I'm going to try really hard to make this one question instead of 8 wrapped into one. But I am very curious about the magnetic aspect of the spirals that you found, and what led you to choose the sled as the tool, and also how they have been analyzed in regard to the magnetic environment they were in when they formed.
Yeah, so that's an excellent question. So we were guided by the fact that the object was very tough, that it maintained its integrity down to the lower atmosphere where the stress was enormous given its speed. And so usually in order, I mean, the toughest meteorites include iron, okay? So we assume that it has iron, and then it would be magnetic. The other reason is that, the background sand on the ocean floor is not magnetic. It's made of non-magnetic particles. So if we were to search for non-magnetic particles, there would be a lot of noise. But we did, so we primarily brought the magnetic sled, but we also had a sluicing device, a sluice that tried to separate material based on density. As soon as we found those magnetic spherals, we focused on them because we had only 2 weeks. We had to be focused in order to collect as much spherals as possible. But with respect to the original object, these are molten droplets that melted off as the object broke into smaller pieces as a result of the fireball explosion. It's a runaway process when the external stress is above the yield of the material, then the object breaks. And if you break an object into 2 pieces, you get twice the surface area that the original object had. And then if you break, so then you get more heat deposited on those pieces because the amount of heat that results from friction scales as the area. So then there is more heat, and therefore, because the area is bigger, and therefore it breaks even more. And so it's a runaway process where the object breaks into tiny pieces, and there is this fireball explosion, similar to a nuclear explosion. By the way, every year there is roughly a half a meter object that collides with Earth, which generates of order the Hiroshima atomic bomb energy. And we just don't hear about it in the news because the atomic explosion occurs at an altitude of about 50 kilometers, so not much damage on the ground. I mean, the Hiroshima bomb caused a lot of damage because it was triggered on purpose to be just a kilometer above the city. But most of the asteroids explode up there in 50 kilometers, and they don't do much. They are usually above the ocean. We don't hear about it, but every year you have such an atomic explosion in the atmosphere.
Yes, thank you very much for coming today. I have 2 questions, actually. With your observatory, I guess the only one you have operational now is at Harvard. Is that correct?
No, I mentioned that we are building 2 additional observatories. So
yeah, the only one that's operational now is
the one at Harvard is only to test the instruments that we are employing. It's it's not necessarily a good site for finding anything unusual, but we were just testing it, and I think the most interesting data will come from Nevada and Pennsylvania.
So with the observatories that you have going so far, have you found anything interesting?
So until
Um,
now, we did not have distances to the objects because we used just one unit. What we are trying to put together, both in Nevada and Pennsylvania, is a system of 3 units observing the same object in the sky from different directions. So that allows us to triangulate and figure out the distances. And so without distances, we can only say that less than a few % of the objects in the sky are outliers, because we can identify 97%. But with distances, I think we will be able to figure out almost all of the objects unless there is something really crazy going on. Because with distances, we will know the speed, we will know the acceleration, and we can compare that to what you expect from drones, airplanes, birds, satellites, balloons. All of these objects have very specific flight characteristics that we can compare against.
So you see there was a few outliers. Were they very small in your observations, or
No, as I
were-
said, we're talking about a few % that could be outliers, but we can't really tell much about them because we don't know the distance to those objects. So with
Okay.
the new data, we will know much better.
Second
Okay,
question
Well,
is,
this is already your 4th question, actually.
oh, I'm sorry.
Anyway.
You get one more, Larry. That's it, buddy.
Okay, this is, have you ever heard of Chris Bledsoe?
Yeah, I know the name.
Yeah, he supposedly can summon up anomalous objects. I wonder if you would consider having him visit your observatory and see
Yeah,
if he can.
we had a visit by a person who claimed to attract the UAPs, but they didn't lead to any discovery. And I'm open to that, but so far I haven't seen strong evidence that they are really doing something. But yeah, I'm open to that. Yeah, let's allow someone else to ask some questions.
Sure.
Yeah, thank you.
Okay.
Harrison, go ahead.
Yeah, so I got some questions about ʻOumuamua.
Okay.
So it came from Lyra and headed to Pegasus, is that right? Like the Lyra.
No, actually, so that's the, astronomers wrote papers about where it came from.
Yeah.
In fact, there is the so-called local standard of rest, that is the local rest frame of the Milky Way galaxy. So that's the frame that you get to when you average over the random motions of stars in the vicinity of the sun. Okay, so if you take, like, let's say the nearest 1,000 stars near the sun, they have some random velocities of about 20, 30 kilometers per second, but you can average and you get to the rest frame, the local rest frame of the Milky Way, okay? And the sun is moving relative, of course, like any other star moves relative to that frame. ʻOumuamua was almost at rest in that frame. So it's basically the sun bumping into it like a giant ship bumping against the buoy. So ʻOumuamua was not coming from another star. It was actually almost at rest in the local frame of the Milky Way, and then we bumped into it. And moreover, it's meaningless to search for the star that it came from, because the size of the solar system, if you go all the way to the edge of the Oort cloud, that edge is half the distance to the nearest star, okay? So if you imagine the nearest star, Proxima Centauri, having an Oort cloud of its own, then the 2 Oort clouds are actually touching each other, okay? So basically, you can think of the Milky Way galaxy as being filled like, a group of billiard balls that are touching each other. Now, if an object came from some direction, it basically passes through a huge number of such Oort clouds, and you would not be able to tell where it came from just from the direction. You have to know when it started the journey, and we don't know how long ago it started the journey. So there is no way of associating an object like ʻOumuamua with a specific star. But what we can say is that it definitely originated within the disk of the Milky Way galaxy because it was nearly at rest in that frame. You know, it couldn't have come from the halo of the Milky Way galaxy, for example.
Okay. Yeah. So with that, so where it came from, is there any significance to where it's going? Like if it were to come from around that area, do you think it would have a better idea to, like if I was to shoot something off somewhere, it would be the best idea to do that?
No, I mean, so in my book, Extraterrestrial, I talk about possibilities and I say, you know, it was sitting at rest. So you could think of it as maybe a relay station for signals or, you know, I wouldn't think that it was like a messenger, like a probe that was sent from one point to another to explore the other point, but more like an object that was, you can imagine a grid of those objects in interstellar space, and we just bump into one of them every now and then.
Okay, that makes sense. So, well, thank you.
Thank you for your presentation. And personally, I'd like to say that I appreciate someone from the academic community who has an open mind to the fact that we may not be alone. Have you always possessed the confidence that we are not alone, or was there an event in your life that triggered a confidence that we may be not alone?
No, it sounds like the most plausible assumption to make. You know, it's just like the Copernican principle that says that we are not privileged, right, in terms of our location. That's what Nicolaus Copernicus argued. And the church, of course, insisted that we are at the center of the universe. And I actually gave a lecture in celebration of 350 years to the birth of Nicolaus Copernicus in its birth town, Torun in Poland. I talked about the next Copernican revolution. So to me, it sounds very plausible that this, you know, it's more plausible that this is the case than the other way around. Because why would we have such a miracle? I mean, also I can think of my daughters when they were young, you know, at home, they thought that they are unique and special, but as soon as they left home, they realized that there are many kids like them. And so our civilization is not mature yet, because every time we look around, we realize that we are not unique and special. I mean, at first we thought, oh, maybe other stars don't have a planet like the Earth. It turns out they do. And I think the same applies to biology. It's probably everywhere. Microbes are everywhere, but even intelligence is, is replicated. I would argue probably at least millions of times, if not billions of times. But most, if you ask, are they alive right now? Not necessarily, because, for example, most humans are dead. You know, there were 100 billion humans on Earth over the past few million years, and you can ask, where is everybody? And the answer is dead. I mean, there are only 8 billion alive right now. So the same must be true for alien civilizations. Most of them are dead, but we can find evidence that they existed by doing space archaeology.
Okay. A question about the observatory in Chile. Is that the one with 6 mirrors? They have 6 different mirrors that are synchronized together?
No. That's a different telescope. You're talking about the Giant Magellan Telescope, which is to be built in 5 years or so. The one I'm talking about is called the Rubin Observatory, which has one giant camera that I showed with 3.2 gigapixels. It's basically tiling the sky. It looks at a small portion of the sky, but then moves from one point to another. And every 4 nights, it scans the entire southern sky. So it's a survey telescope, and the data will be public. So it will be very exciting. So just I highly recommend watching the inauguration of the first images, you know, from that telescope on Monday, this coming Monday at 11 a.m. Eastern time. It will be 10 a.m. your time. And you can find it by Googling the Rubin Observatory first images. I'm sure that you will find that link. Okay.
Thank you very much.
You're welcome.
And I think maybe we can post that link on our website as well to make it easier to have folks be able to access that.
It was really a great pleasure to speak with all of you. And keep doing what you're doing, and hopefully within a year or a few years, we'll know much more about our cosmic neighborhood.
Well, thank you so much. We greatly appreciate your time. And thank you for sticking around enough to answer some other questions. We could probably keep you here for hours asking questions, honestly.
Well, the thing is, it will be much, I mean, at some point we'll have answers, not just questions. And that's what I'm seeking. And next week we are building the new observatory in Nevada. So stay tuned.
We will do that. And I know what I'll be doing on Monday. So thank you so much for your time, Dr. Loeb.
Thank you, Dr. Loeb.
We wish you the best success in finding some answers for us.
Thank you. Pleasure meeting all of you.
Bye-bye.
Bye-bye.
Honey cream. That's pretty good. Not bad. Oh, you guys are still here. Okay, well, since you're still here, please subscribe. Please like. We're really trying to grow the channel as best we can. We can use all the help we can get. So, there should be like a video over here somewhere. Click on that. Watch another one. Thanks. This is some great science. Wow.